Alright, so as for, okay, let's look at our first vocabulary, guys. We have coordinates, okay? And that's the number line that corresponds to a point on a number line. So if you look at our example here, we have coordinate of A right there. That's the point. It's sometimes a variable like A, for example, but sometimes it's normally given as a value like -1. All right, so be aware that there's two different values for the coordinate of A. So be aware of that. All right. And as for distance, well, that's the absolute value of the difference between 2 points. So here, in our example here, if we have a line, A and B here, the distance between A and B will be the absolute value of the difference. And that's it. Okay, so our next vocabulary we have here is congruent segments. So when two segments have the same length. So if you look at our example here, we have segment A and B here, and then we have segment C and D, and we say that they're congruent by this little symbol here. And if we want to write it out, we can write it out as segment AB is congruent, equal with a little squiggly line on top, or congruent to segment CD. Okay, so the midpoint. A midpoint that divides, or actually a point that divides a segment into two congruent segments, or two equal lengths, right? So here we have a segment AC here, we have the midpoint B, it's right at the middle, and it divides the segment into two equal lengths, or two segments here. And B is the midpoint of AC. Okay, so for our last vocabulary, we have segment bisector. That is a point, line, or ray, or other segment that intersects a segment at its midpoint. So the example here, we have segment AC over here, and then we have a line here bisecting, cutting the segment AC here exactly in half, okay? And here we have B as our midpoint here, and so L is a segment bisector of AC because it cuts this line segment exactly in half, in two equal lengths. Okay, so 7.3, you guys, it's measuring segments. Today's the 23rd, by the way, on page 68. I hope all of us labeled that on our notebook already. Yeah? Okay. So, let's see here. The fifth postulate, guys. Continuing from last time, you guys, the fifth postulate. Okay, so that's the ruler postulate, by the way. And it says every point on a line can be paired with a real number. So, and this goes hand in hand with, the coordinate definition, right? Every coordinate is paired with a real value. So here we have the line AB here. We have the values of A and B as lowercase a, lowercase b here. So the difference, or actually no, the distance between them, A and B here, that's the absolute value, guys, of A minus B, right? Let's go ahead and write that down. Okay, so postulate number 6, or the segment additional postulate. And it says if 3 points A, B, and C here are collinear, in other words, they lie on the same line here, then, and of course B is in the middle between A and C here, then AB, segment AB here, plus BC, B and C, is equal to the total length, right? AC, segment AC. Okay, so example number 1. So once again, we have the segment K to D, and M is the midpoint. It cuts the line segment into two equal parts here. Once again, this line means that they're congruent, right? And that means that the length of KM and MD, they're the same, okay? That's what that means. So from there, since KM, the segment KM is equal to MD, why don't we just go ahead and set these equal to each other, right? Because they're the same thing. So let's go ahead and do that. So KM is equal to MD, congruent, so that means that 2x plus 4 here is equal to 3x plus 2. And then from there, we simply solve for x, okay? So From there, you subtract 2x from both sides. We get 4 on the left-hand side, and on the right-hand side, we get x plus 2. Subtract 2 here, and so we get x is equal to 2. Now we know what x is, right? We know that Km is equal to 2x plus 4, and that MD is equal to 3x plus 2. So that means that Km is equal to 2, times 2 plus 4, and that's equal to 4 plus 4, right, which is 8. All right. And then MD here is equal to 3 times 2 plus 2, and that's 6 plus 2, and that's also 8. But of course we know that since they're congruent, by default it should be 8, right? All right. And that's example number 1. Okay, so for example number 2 here, these are the givens, and we're supposed to find RC, right? RC is our total length here, guys. It's total segment here. And we have RW, which is half of it, and then we have the other half. And, well, how do we know it's half? Well, because of these signs, right, these symbols. It means that they're congruent, okay? So very similar to the previous problem, guys. What do we do? Let's see here. We're adding here, right? Can you see that we're adding here, you guys? By postulate number 6, you guys, add segments, right? So let's go ahead and do that. Or actually here, let's go ahead and solve for x first, and then we'll add later. Why not, right? So solving for x, let's go ahead and set them equal to each other, just like our previous example, okay? So if we have 3x plus 6 here, and this is our w, by the way, to WC. And we know that WC is 7x plus 2 here. Solve for x, so go ahead and subtract 3x here, subtract 3x here. This goes to 0. We have 6 on the left-hand side, 4x plus 2. Subtract 2 from both sides, and then we get that 4x is equal to 4. That means that x is equal to 1 if we divide by 4, right? So there's our solution for x. Okay. And then by postulate number 6, we know that RC is equal to RW plus WC. And we know that RW is this, right? 3x plus 6, but we know what x is. X is 1. So if we substitute that for x, we get that 3 times 1 is 3, plus 6 is 9, plus WC, of course it should be 9, but let's go ahead and check it, right? So 1 here, so 7 times 1 is 7, plus 2 is, again, 9. So 9 plus 9 is 18. And so RC is 18, you guys. That's our total length here. And that's a segment, by the way. Okay.